All right, so this video I'm starting with the just the examples within lesson 3-2. So again, if we look back, some of the notes I've taken some of these notes to fill them in as reference. So to start, we've got our graph of a basic sine curve, cosine curve. So sine of 0 is 0. So we would start that first point there. Sine of pi over 2 is 1. Sine of pi is 0, and we go around to those critical points. And that's how you graph a basic sine curve. From there, you freehand sketch the curves to meet that requirement. Cosine is no different, except you're plotting different points. So cosine of 0 isn't 0, it's 1. Same thing, cosine pi over 2 is not 1, it's 0. So things have been shifted, but you put in those same critical points every 90 degrees or every pi over 2, and then you fill in the curve with a freehand sketch. Tangent is the one that's a little bit different. Tangent of 0 is 0, so we plot that point. We know that tangent pi over 4 is 1. The other number we know would be tangent of pi over 2 does not exist. And what that does is it creates an asymptote, a vertical asymptote that we approach but we never reach. And so if you were to plot, say, tangent of pi is also 0. Tangent of 5 pi over 4 is 1, and 3 pi over 4 is negative 1. So those three critical points, maybe I could even update this. Let me give that a little bit better curve. So it's much more of like it comes in and then really curves back around like that. So it looks like a cubic function, like y equals x cubed. But anyways, and then that repeats itself every pi. So 0 was a point, 0, 0, and then pi 0, 2 pi 0, and so on. So if we were to graph multiple cycles, that would just be that repeating cubic curve. Here I did point out a few things, well, it's in the handout key also, but the amplitude, just to note, is always a positive number, and that is from the midline to a peak or a midline to a valley, but that midline should be on the x-axis to start. So anything up or down from the x-axis is what we consider a vertical shift, and we consider the period of the graph one cycle. So in this case I picked a valley to a valley because in this view that's really about the only thing you can see repeating. We don't see the second peak. In this case we were, it looks like we were graphing a cosine curve because I've defined the phase shift. See, cosine should have started its peak right at the y-axis, but it didn't. It got shifted over, so we consider that shift from y-axis to this peak the phase shift. So let's move on. I forgot we had these up here. So I noted that amplitude is always positive, so we note that as an absolute value of a being the distance from the midline to a peak or a valley. C is just that number. What is the distance horizontal? Vertical shift, that's again from the x-axis up or down. That's a straightforward value. The period, though, is where it's a little bit tricky. The period of a sine or cosine curve is always 2 pi. So if we want to say that we've changed the period to squish it together so it's more frequent, or to stretch it out so that's a much longer peak-to-peak distance, the period was 2 pi. If we divide that by b, that is how you find the period. So if I know that my period is just 1 pi, it's repeating every 1 pi instead, we would say pi is equal to 2 pi over b. We solve for b, and by doing that we find that the value of b is the number 2, because 2 pi over pi is just 2. And these four letters, a, b, c, and d, get put into our basic sine and cosine function equations. So let's put that into practice here. Example 1, find the amplitude, the period, the phase shift, and vertical shift. How I'm going to go about doing this is just starting by on the left-hand side, and again, pardon my shorthand, but I don't have a lot of room and my pen is kind of bulky. So amplitude, and I'll just shorthand some of this, but I'll go in order, and then PS for phase shift, VS for vertical shift. So our amplitude is pretty straightforward. It's the absolute value of A. And in this case, A is just this number out front too. So our amplitude, we can just, whoa, what am I doing? Just simply write and copy and paste that number. So my pen works, amplitude is 2. But before we can go any further, our period, our phase shift, those are affected by these middle numbers here. And what you'll notice though is that this has cosine of the quantity 2t minus pi. And the way we're going to teach you to do this is just the same way as we taught you when we were modifying traditional polynomial graphs. So what I mean by that is our standard function here is f of x, a, in this case it's cosine b times the quantity x minus c plus d. So there's our basic form. And what you'll notice though is that b is pulled out front, it's factored out, and then x minus c, where x, in this case it's t, right? We can change those variables all we want. But the variables by itself, there's no leading coefficient, it's been factored out. Here we have a leading coefficient of 2, and that doesn't match. So we really need to rewrite, we need to start over with our equation and say that that is equal to 2 cosine of 2 t minus something. Well, we want to end up by redistributing the 2, like 2 times the first term, we get 2t. 2 times the second term, we need to get to pi. So inside the parentheses, we write that as pi over 2 minus 1. And that way, when we take the 2 times t, we get 2t. We take 2 times pi over 2, we just get our pi. And then minus 1. So now we can move forward. So our period, remember our period is 2 pi over b. So let me write this in green. Period is equal to 2 pi over b. B is, again, is that number out front of that x term, so that's a 2, so 2 pi over 2. So what this has done, by putting a 2 out front, that's taken our frequency of our peak to peak from 2 pi down to just 1 pi. So that is our period. Our phase shift in the standard form, phase shift is just the c value. We are matching signs, minus sign, sorry, over here, minus pi over 2 and minus c. What that means is our c is exactly pi over 2. So please note that if this is minus pi over 2, the phase shift is not minus pi over 2. In the equation, it's a standard form minus c, so they match. Vertical shift, pretty straightforward. It's a minus 1, so vertical shift, negative 1. So you can write these as like down 1 for vertical shift if it's minus, or up 1 if it's positive. Phase shift, it's the same thing. We can phase shift positive pi over 2. You could also say to the right pi over 2. If that was, like let's look at B here, you'll see that's a plus and a pi over 4. Whatever your phase shift is, that's going to be a phase shift to the left. Because those signs don't match, the phase shift is a negative value, so like negative pi over 4 or negative pi over 2, which would be a phase shift to the left. So we've completed all of these. We can box that in and move on to B. Yeah, let's do B really quick. I know we're at 9 minutes, but I want to try and get this in one video. So let's get at it. So green. I'm going to rewrite this as negative 3 sine of 1/2. So I have to factor out, it's t over 2 right now. I just want t by itself. So 1/2 t plus, now how do I get the, I'm going to finish that out, the c value. Well, in order to get C value, it's a standard process. Take the number. So in this case, it's 1/4 pi. So take 1/4 pi divided by the number out front. So 1/4 divided by 1/2. And what you get is 1/2. So t plus pi over 2. When you take 1/2 times t, we check 1/2 t makes t over 2. 1/2 of pi over 2 ends up pi over 4. So we're back to what we had. So now that we have our standard form, we can evaluate. We can say our amplitude. Now again, it's not -3. Our amplitude is always a positive value, absolute value of the number out front. So 3. Our period. Well, there's some work to be done there. 2 pi over b is 2 pi over 1/2. When you take 2 pi divided by half, it's the same as 2 pi times 2, so we get 4 pi. Our period has gone from 2 pi to 4 pi. What that means is it stretches the curve. Instead of going like this, it's more like this. It's been stretched out. Let's see, so period phase shift, PS. Phase shift in the standard form is pi over 2, but I see it's a plus here, which means that doesn't match the minus c in the standard form. So we're going to call that a negative pi over 2 or a left pi over 2. And by far the easiest one, our vertical shift is just 2 or up 2. So there you have it, 12 minutes, but we've got an introduction, we've got examples 1A and 1B done. Next video will be a little bit shorter, sweeter. What we're going to do is we're going to take those definitions and write them into the equation, which is the opposite of what we just did here. So hope you enjoyed. I will get to the next one here shortly.